Here are 10 space stories you can listen to in English. Now, let's get started. Near light-speed jet? Did you know that some black holes shoot out jets that travel almost as fast as light? Some objects in space, called quasars, have a black hole at their center. From the top and bottom of the black hole, streams of plasma, called jets, are sometimes released. These jets are extremely fast. Their speed can be more than 99% of the speed of light. Scientists think these jets are made of material that did not fall into the black hole. Instead, powerful magnetic fields around the black hole accelerate and push this material out. These jets can travel a very long way through space. In fact, they can reach places that are millions of light years away from the quasar. Black hole spaghetti. Did you know a black hole can turn you into a noodle? This strange idea is a real scientific concept called spaghettification. When an object gets near a black hole, the gravity pulling on the part closer to the black hole is much stronger than the gravity on the part farther away. This huge difference in force is called a tidal force. The tidal force stretches the object vertically, making it very long and thin, just like a piece of spaghetti. However, you might not feel this effect before entering every black hole. In the case of a supermassive black hole, the tidal force only becomes deadly inside the event horizon. The event horizon is the point of no return. Therefore, it is calculated that an object can pass the event horizon of a supermassive black hole before it gets stretched. The spaghettification would happen later, after the object has passed this point. Universe's brightest light. Did you know there is something in space over 1 trillion times brighter than our sun? It is called a quasar, and it is the brightest object in the universe. The famous quasar 3C273, for example, shines with the light of about 25 trillion suns. That is more than 1,000 times brighter than our entire Milky Way galaxy. This incredible light is created by a supermassive black hole at the quasar center. This powerful light does not come from the black hole itself. Instead, it comes from a spinning circle of hot gas and dust around the black hole, called an accretion disk. When matter in this disk falls into the black hole, it creates a huge amount of heat and light from friction. This process is a very effective way to make energy. It is more than 10 times more efficient than the nuclear fusion that powers our sun. Monster in galaxy center? Did you know that a giant monster lives in the center of most galaxies? It is true. These are called supermassive black holes. They are very, very heavy, with a mass millions or even billions of times greater than our sun. Our own galaxy, the Milky Way, has a supermassive black hole at its center too. Its name is Sagittarius A. Sagittarius A has a mass about 4.3 million times that of the Sun. However, its size is surprisingly small for how heavy it is. Its radius is only about 12 million kilometers. This is about 1/5 of the distance from the Sun to the planet Mercury. On the big scale of a galaxy, this monster is very compact. Space-bending gravity. Did you know that gravity can bend light? A black hole's gravity is so powerful that it can change the space around it. This creates something called the gravitational lens effect. When light from a star far behind a black hole passes by it, the gravity bends the light's path. From Earth, this can make one object look like multiple objects, or it can even appear as a ring of light. This is not just a theory about black holes. In 1919, during a solar eclipse, scientists observed that the sun's gravity bent the light from distant stars. This observation proved that Albert Einstein's theory of general relativity was correct. The effect from a black hole is an extreme example of this, as its gravity is much stronger than the sun's. Surprisingly small quasar. Did you know that the brightest objects in the universe are surprisingly small? A quasar's main body, the part that gives off light, is only a few light days to a few light years across. This is just a little larger than our solar system. When you compare it to the size of an entire galaxy, a quasar is a very tiny area. Scientists figured this out because a quasar's brightness changes over short periods of time, like a few hours or a few months. For the brightness of the whole object to change together, the object must be small. The light source cannot be larger than the distance light can travel in that period. This observation is a key piece of evidence for estimating a quasar's small size. Gravity slows time. Did you know that strong gravity can make time move more slowly? Near a black hole, this really happens. A black hole's powerful gravity changes the space and time around it. As you get closer to the black hole's event horizon, which is the point of no return, time passes more slowly for you. For a person watching from far away, it looks like your time has stopped completely. This idea is not just a theory about black holes, it is also useful on Earth. We use this knowledge for GPS satellites. The satellites are far from Earth's surface, so gravity is weaker for them. This makes their clocks run faster than clocks on the ground by about 38 microseconds every day. To make GPS work correctly, scientists must use the theory of relativity to adjust for this time difference. Spacetime ripples. Did you know that space itself can shake like the surface of water? When two black holes crash and merge, they create ripples in spacetime. These ripples are called gravitational waves. The waves are not just in one place. They travel across the universe at the speed of light, which is 300,000 kilometers per second. This powerful event sends out information about the black holes far into space. For almost 100 years, these waves were just an idea from Albert Einstein. But in 2015, a special observatory called LIGO detected them for the first time. The waves came from two black holes that merged about 1.3 billion light-years away from Earth. This was a very important discovery. It was the last part of Einstein's theory of general relativity that scientists needed to prove was real. Lost middle-sized black hole. Did you know that scientists could not find a certain size of black hole for a long time? They found small ones and very large ones, but the middle-sized ones were missing. These are called intermediate mass black holes, and they have a mass 100 to 100,000 times that of the Sun. Because they were so hard to find, they were a big puzzle for astronomers for many years. Recently, scientists have started to find these missing black holes. They find them by observing special signals like gravitational waves. One popular idea is that these black holes are born in the center of a globular cluster, which is a group of many stars. In these crowded places, many smaller black holes can crash and combine again and again. Through this process, they grow into a larger, middle-sized black hole. Fast-eating quasar. Can you believe that something in space can eat about 10 Earths every second? This is true for some very active quasars. A quasar is a very bright object in the center of a galaxy. Active quasars swallow a lot of material. A normal active quasar eats material equal to 10 times the mass of our sun in 1 year. Some very active ones can eat 1,000 times the sun's mass in a year. This eating is why quasars are so bright. When a quasar swallows material, it produces a huge amount of energy and shines very brightly. However, this activity cannot last forever. When a quasar uses up all the material around it, it has no more food to eat. Then, it will stop being active and lose its amazing brightness.